So, what does it really take to build something complex right from scratch? We're about to find out. We're going to dive deep inside a real-world university software project, deconstruct how they pulled it off, and uncover some seriously powerful lessons about teamwork and planning that you can use pretty much anywhere.
And let me tell you, the challenge here is huge. This isn't some simple little app. We're talking about a team of students tasked with building an entire flight management system from the ground up. That means juggling multiple, interconnected parts that all have to talk to each other and work together flawlessly. Yeah, the pressure is on from day one.
And there is absolutely zero time to waste. Just look at this timeline. It's a punishing schedule. By week 12, the team has to be finalized. Then, boom, boom. 2 major assessments are due just a few weeks apart, all leading up to that final, high-stakes oral exam. The clock is ticking, and it's ticking fast.
Okay, so how do you even begin a project this massive? Well, you start with a plan. This whole first phase is all about crafting that initial blueprint, and this is so important. It's about laying a rock-solid foundation for everything that's going to come later. Honestly, it's probably the most critical part of the entire project. Their approach is incredibly structured. It follows this really clear 6-step process. First, they break up the system and give people ownership. Then they define the requirements, map out all the connections, sketch out the user interface, and plan the actual logic. And here's the kicker. Notice that right in the actual code is the very last thing on this list. It is all about planning before you produce.
Let's zoom in on one of those steps, the class diagram. What is it? Think of it exactly like an architect's blueprint for a high-rise building. It's the super detailed map that shows every single component, but more importantly, it shows how information is going to flow between them. You get this right at the beginning, and you save yourself from the whole structure collapsing later on.
This quote just nails it. It's the plan before you start laying bricks. That's how they described planning the logic with pseudocode. I mean, it makes perfect sense, right? You wouldn't start building a house without knowing where the doors and windows are supposed to go. Same idea here. You outline the code's logic in plain English before you get bogged down in all the complicated syntax.
And you know, this is really how modern software gets built. Instead of trying to create this entire enormous system all in one go, they build it piece by piece. One feature gets built, it gets tested till it's perfect, and only then do they move on. This whole build, test, repeat cycle makes a gigantic task feel manageable, and crucially, it stops tiny little bugs from turning into project-ending disasters.
All right, so they've got their blueprint, they have their building strategy, but how do you actually manage the day-to-day construction when you've got a whole team involved? Well, this is where professional tools and methods become absolutely essential for keeping everybody in sync.
And the framework they're using here is called Scrum. What it does is give the work this really powerful rhythm. The entire project gets broken down into these short, intense bursts called sprints, and daily check-ins make sure the whole team is on the same page. It forces constant communication and keeps things moving forward, so nobody can wander off track for too long.
Now, to manage this whole Scrum process, they're using pro-level tools like Jira and clip². But these aren't just fancy to-do lists. Their single most important benefit is that they create a visible audit trail, a clear, documented history of who did what and when they did it.
And that audit trail? It is absolutely critical. Because for this project, how the team works together is graded just as heavily as the final code they produce. They have to document everything: meeting notes, big decisions, who's responsible for what. The journey truly matters just as much as the destination.
And now we get to the final hurdle. And it's a big one. It is not enough to just hand in the code and call it a day. Nope. Every single student has to survive what's called the viva voce, a live, oral defense of their work, face-to-face with the examiners.
The stakes couldn't be clearer. This is rule number 1, and it's brutal. No working code, no pass. If your program doesn't run when they ask you to demonstrate it, you fail, period. There's no partial credit here, no room for excuses. It's a stark reminder that the whole point is to build something that actually works.
So let's be crystal clear on this. There are 2 non-negotiable conditions to pass. You must have working code you can demonstrate, and you must show up in person for that oral exam. If you fail on either one of those points, it is an automatic fail for the entire project. The pressure is just immense.
Okay, so let's say you have working code and you show up. What are the examiners actually looking for? Well, this isn't just about proving your program runs. It's a really deep dive into your personal understanding. Can you explain not just what your code does, but how it does it? Can you justify why you made a certain design choice? They are testing for true, deep ownership of your work.
Just imagine it. An examiner points to a completely random chunk of your code and asks that simple but terrifyingly powerful question. Why did you write this code this way? You simply cannot fake the answer. You either know your work inside and out or you don't. And in that moment, there is absolutely nowhere to hide.
So, after taking this whole process apart, what are the big lessons here? What can we pull from this one academic project that applies to any team in any field trying to build something complicated?
Well, first, let's just appreciate the complexity. It all comes down to this number, 8. Now, 8 might not sound like a lot, but that represents 8 major, totally distinct software components. Everything from finance to passenger flight maps that all have to communicate with each other flawlessly. It just highlights that incredible challenge of integration that you find in any large project.
When you boil it all down, this project's success really rests on 3 universal pillars. First, a solid blueprint, because that detailed upfront planning prevents total disaster later. Second, a structured process, like Scrum, to bring order and rhythm to the chaos. And third, accountable defense, the simple principle that you have to be able to stand up and explain and justify the work you did. And these ideas apply to anything, from building software to launching a marketing campaign to renovating a house.
And this all brings us to one last provocative question to leave you with. When you're tackling something really complex as a team, what is the single most critical element for success? Is it having perfectly clear requirements from the very beginning? Is it flawless, constant communication between every team member? Or is it rigorous, non-stop testing? This project shows you really need all 3, but it's worth asking, if you could only be a master of one, which would you choose? Some to think about.